AOPS Volume 1, the basics, number 92. Find the value of A if the 5-digit number of 12A3B is divisible by both 4 and 9, and A does not equal to B. So, approaching this question, we must understand the divisibility rules for 4 and 9. 4 can only be divisible by any number, such as 324, if the last two digits as a number is divisible by 4. So, in the case of 324, 24 is divisible by 4, hence 324 will be divisible by 4. What about 316? 16 is the last two digits of the number, hence treat 16 as a whole number by itself. 16 is divisible by 4, hence it is 316 as a whole divisible by 4. That is the divisibility rule for 4. And what about 9? Nine's divisibility rule is that the sum of numbers, the sum of all the integers within a number, no matter how many digits that may be, must be divisible by 9. So 3 plus 2 plus 4 is 9. 9 divided by 9 is 1. Hence, this can be divisible by 9. And this will give us a result of 36. And what about 36? 3 plus 6 is 9. 9 divided by 9 is 1. Hence, 36 can be divisible by 9 as well, which is equal to 4. 4 is not divisible by 9 because 4 plus 0 is not divisible by 9. So that is the divisibility rule for 9. And with these two rules, we can begin to apply it to this question. So first, in the case of 9, 1 plus 2, 1 plus 2 plus A plus 3 plus B must be divisible by 9. Simplify this, we get A plus B plus 6 is divisible by 9. But what is the restriction of A plus B plus 6? A good trick when you're dealing with questions such as this, it is always good to find the restriction of what A plus B plus 6 can be. And what is the highest number A plus B plus 6 can be? Well, if we assign A the largest possible integer, a one-digit integer, which is 9, and we assign B to be equal to 9 as well, 9 plus 9 plus 6 should subsequently give us 27, meaning that A plus B plus 6 cannot surpass 27. So what are multiples of 9 that are below 27? Well, the only multiples are 9 and 18. I know this because 9 times 3 is equal to 27. So the only integer multiples of 9 below that are 9 times 2 and 9 times 1, which is 9 and 18. So A plus B plus 6 must be equal to 18, and A plus B plus 9 plus A plus B plus 6 rather, sorry, must be equal to 9. So let's write that down. A plus B plus 6 must be equal to 18. A plus B plus 9 plus 6 should be equal to 9. These are the only two possible quantities that the three can sum to. So A plus B is equal to either 12 or A plus B is equal to 3. So now we just limit it down to this. So let us begin to apply some more restrictions on A and B. Well, we know that the divisibility rule for 4 is that the last two numbers must be divisible by 4. So 3B must be divisible by 4. And what number can B be? Remember, treat 3B as a whole number. Okay, so do not treat it as separate entities. So what can B be? Well, B can be equal either to 2 or 6. And the reason why I know this is because 4 times 8 is 32. 4 times 9 is 36. These are the only two integer values of B that can exist. And now just trial and error. There is no other way other than this step. So if I apply B is equal to 6, then and I apply it into here, it must mean A is equal to 6 for the first criteria. But remember, A cannot equal to B. Therefore, B cannot satisfy this first condition. So let's try the second condition. When A is being applied to B when B is equal to 6. When B is equal to 6 for the second possible criteria, A must be equal to negative 3. And does that make sense? It doesn't. A cannot be equal to a negative number. So when B is equal to 6, it is a for sure no. Therefore, it deduces down to be the only possibility to be 2. Hence, if we want to find the value of A with B being 2, then that is just a cinch by applying it into this equation right here, or these two equations. And we can apply it to either one, and I'm going to apply it to the first one. So when B is equal to 2, A must be equal to 10. Well, A cannot be a double integer number, such as 10, so that won't work. And if we apply it to A plus B is equal to 3, A plus 2 is equal to 3, A is equal to 1. This does meet the criteria that A is not equal to B, and that 12A3B is divisible by 9 and 4. Hence, the solution to this question will be A is equal to 1.